Good morning, Mr. Lesham is here, and today we're doing one more lesson about logarithms. Now, there's actually a lot in logarithms, and we don't need to know all of it. So you can see if you've got 67 in front of you, you've got laws of logarithms, and if you can see it says not for examination purpose. So it's in the textbook, but you're not going to be tested on that. I personally want to get a little bit of clarification how much of it you really need to know, and if, at this point I'm not going to teach you something that you don't really need to know. So we will do these we might do these rules next Monday, but for now I will do stuff that you definitely need to know. So I'm actually not teaching anything new today, but it's going to be maybe taking the level 1 up, but it's not too difficult. So I've got 2 to the power of x equals 13, and I want to solve for x. Okay, all these questions basically solve for x. So we've done that quite a lot of times, but I know it's not that easy, so I thought I will do it anyway, just to make sure you get it. Okay, how can I find x? How can I get him down? Come guys, by now I'm expecting some of you to be able to answer that. What is x equal? Let me just do black. Yeah, decimal. X equal? Log, okay? So you always jump between exponent, log, exponent. If the base is 2, it's still going to be base here. Okay? Alright? 13. And you put that in a calculator, and if you can just put that in a calculator, it's going to be some nasty number, probably irrational number. We'll keep 2 decimal places. What is it? Pause for these guys. Right, so we got 3,70, a few more decimal places, but 2 decimal places, that's the case. Now I'm going to just write it in red, okay? The rule that needs to stand in front of your eyes is the following, okay? If I've got, let's say, a to the power of x equal to y, and I want to know what the x is, then I know that x is log y base a. This is like your one rule that you need to remember. Like I said, there's a few other rules, but I don't think you need to remember them. So I'm not going to teach them today. Now let's look at this one. So I have 2 times third to the power of x equal 24. Okay, so now I have an exponent, so I know at some point I'm going to have to go to a log. But before I go to the log, what's the first thing? Divide by 2. So a third to the power of x equal 12, and then x equal?
Log a third 12.
Log base third 12. And let's agree from now, you guys are going to have to put the calculator. Doesn't matter. Obviously you can't leave the answer like that, but we're not going to spend time on this. You can do it on your own, okay? Now let's move on to something a little bit more difficult. 7 to the power of 2x minus 3 equal 60. Okay, I want to solve for x. So what do I do now?
What?
7 to the power of 2x minus 3 equals 60. So it's nothing new here, but it's slightly higher level. What's going on here? So what should I do now?
See if 60 has any.
So I want to know what this thing is, right? So okay, so I'll start here. 2x minus 3 equal what?
Equals log.
Log base 7 60. And before you put that in the calculator, a word of advice, don't put it in the calculator because it's not going to be a pretty number. First we'll find what x is, okay? So we're going to say, alright, 2x equal, how do I move the 3? Well, I don't need to ask you, you know that, right? 3 plus log 60 base 7. Finally, I want to find out what x is. I'll divide the whole thing by 2, right? So all the normal algebra stuff still works, okay? 3 plus log base 70 is 60. All of that divided by 2. That you put in your calculator and you're getting a number. We happy with that? Okay. I'll pause here. Let's get you to work a bit. So this is probably the last question for me. I'll see if there's anything else that we should do. this kind of question we did last year. I imagine there will be a little twist, a log twist at the end. But we have done these sort of stuff. We want to solve for x. How should I solve that? Okay, I'll pause and what do you think? Alright, like you said. Right, guys, well done. So you gotta see that you've got 2 to the power x, and you also have 2 to the power x hiding here.
Oh.
So you need to peel that out. It's basically going to be 2 to the power 3 times 2 to the power x, right? We're using the exponent in reverse. Minus 2 to the power x equals, let's move the 42 to the other side. Already I'm anticipating something here. And I know 2 cubed is just, it's 8, isn't it? So I've got 8 times 2 to the power x minus 2 to the power x. Actually, I should have left that 42 on the other side, sorry. Okay? Right. What should I do now? There's a couple ways of doing it, yeah. You can take a common factor out, or you can use what we call the K method.
Oh, yeah.
Yeah? I think you guys like the K method. Huh? So we're gonna write 2 to the power x. That's like the thing I'm working with, is we call it K. Alright? So what do I have here? I've got 8k minus k equal 42. Well, that's easy. That's 7k equal 42, which means that k equal, anyone do it in their head? 6.
No.
But did I finish now?
No.
No, I don't want to know what k, I want to know x. So I'm going to write 2 to the power of x equals 6. Okay? Now normally here, last year, we would have here some kind of number which is a power of 2.
Yeah.
So as I thought, there's a log twist here, right? This is not, I can't write 6. You can't put shift factor and write 6 is not 2 to the power something. So we have to use the log. So what is x equal to? You know how to do it.
Log 2.
Log base 2, 6. Not x, 6.
Okay.
Yeah? And you put that in the calculator. Alright guys?
Yeah. Yes, sir.
Awesomeness. Alright, let's do some work.
No.
That's it. Bye bye.